Hello everyone, this is Vijayasri, working as an assistant professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discuss about binary searching technique in C. Overview of the session. So, in today's session, we are going to discuss about definition, working principle of binary search, time complexity, pros and cons. In the last session, we have discussed about linear search technique. Linear search can be performed in both sorted list and unsorted list of elements in an array. But coming to binary search can be performed. Binary search technique will work only on sorted array or sorted list of elements in an array. Working principle. Start by checking the middle element of the array. So, if we consider this is an array, suppose the array name is A, index starts with 0, 1, 2, 3, so on. So, first point is, first we'll find middle element, mid value of the given array. So, if the target is equal to the middle element, return the index. Next point is, let us suppose the target value is the key value which is equal to the middle element, will print the index which is present in that location. If the target is smaller, if the target key is smaller, repeat the search in the left half of the array. Well, first we'll find out the mid value. Suppose mid value is this. So, if the target value, we are considering it as a key value which I want to search in the list of the elements which is less than the key, which is this key is less than the mid. Then we have to search in the left half of the array, and which is larger. Then we will search in the right half of the array. So, mainly this technique works on divide and conquer. That means the given array is divided into sub-arrays. This process continues, halving the search space each time until the target is found or search space is exhausted. So, the time complexity of this is order of 1, average and worst case order of log n. Then space complexity is order of 1 or order of log n if it is an iterative version or a recursion. Then pros. It is very efficient. It works on a larger data set. Requires fewer comparisons than linear search, because linear search is also known as sequential searching technique. That means it will search in an array. It will search one by one. But coming to binary search, it divides the given array into two halves. In place, especially with the larger sorted data, requires fewer comparisons than linear search, especially with larger sorted data. In place search, requiring no extra memory for sorting. Then cons. Only works on a sorted data. Yes, as I told you, the first, it works only on a sorted list of elements. Not suitable for unsorted data. It is not suitable. Binary search will not work on if we have an unsorted element in the list. We cannot perform binary search. Requires knowledge for the sorting order. If we have this, if we have unsorted elements, if we want to perform a binary search, then we have to first sort the given elements. First we have to sort elements using any sorting technique like bubble sort, quick or incision sort. Then we can work with binary search on that list of elements in the array. Example. Suppose here consider the example list of elements. Consider the list of elements are 6, 10, 18, 24, 26, 46, 60, 64, 72 and 90. So, these are the list of elements which I consider here. So, array name is A. Suppose the number of elements number of elements are n. N is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of elements are 1, 2, 3. Number of elements are 10. So what is the first key point? The working principle of binary search is first we have to find out the mid value of the array. Now whatever the element I want to search in this list, I am considering that as the key. Here I am taking that as the key. So here the key is 60, suppose. The key value, that means the target value is 60. I want to search whether 60 is present in the given list of elements in an array or not. Binary search will work only on the sorted data. If you observe, whatever the data I consider in this list are in sorted order. So to find out the mid, first we have to find out the mid, then we have to check whether the given key, we have to check whether the given key is equal to the mid value. If not, if this condition is true, then we have to print the key is present in that particular location. If not, we have to check whether the key is less than mid. If this condition is true, we have to work on the left array. Then key greater than a of mid. So this is the given list of elements. Always this is the lower bound of the array and this is the upper bound of the array. Now here I am considering this as the low, left side of the array. I am taking it as the low and this upper bound is the high, the right, or you can say it is a left or a right. Now first thing we have to find the mid value. Mid, how to calculate the mid? Mid is equal to low plus high by 2. Low plus high by 2. So here low is equal to, so here I am writing mid value. Low, high and mid. So low here 0 and high here 9. So to find out the mid value, that is 0 plus 9 by 2. 0 plus 9 by 2, that is 4.5. So we'll consider the floor value, that is 4. So mid value is at now 4. Now we have to check with these three conditions whether the given element is found in the given list or not. So the first condition is key equal to a of mid. Here I consider the key value as 60. Now I am going to check with this first condition, that is 60 equal to a of mid. A of mid is a of 4. So in a of 4 we have 26. Is 60 equal to 26? No. This condition is false. Next we have to check with the second one, that is key less than a of mid. Now key is 60 less than a of mid is a of 4. Here we calculated a of 4. In a of 4 we have 26. Is 60 less than 26? No. Then we'll go with the next condition, that is key greater than a of mid. 60 greater than 26. This condition is true. That means here the key value which I want to search in the given list is greater than the mid value. So that means this 60 is after mid value. That means it is right side of the mid. So in such a case, in this case, the low is not here. Low has to be shifted after the mid. If this condition is true, then low is equal to mid plus 1. Because, so in this case, we know that the low value has to be shifted to its right. Because the value which I want to search is after the mid value. It is not there in the left of the array. Why? Because, why I am sure about this? Because the elements, whatever the elements present in this list are in sorted order. So in such a case, we have to shift the low value. Low is equal to mid plus 1. Now low is at 5 because mid is 4. 4 plus 1. 4 plus 1. Now it is 5. So low value is now 5. High will remain the same. So high is 9. Again we have to find the mid value. Now the search space is this. Now to find out the mid value, we know that mid is equal to low plus high by 2. So now low is 5 plus 9 by 2. So here it is. So it is 7. Now mid value is it 7, not here. Now here we have mid. Now here we have low. So now mid is 7. Again we have to go with these 3 conditions. We have to check whether key equal to A of mid, or key less than the mid value, or key greater than the mid value. Now key is, my key value is 60, which I want to search whether it is present in the given list of elements or not. Then equal to A of mid. Here A of mid is A of 7. In A of 7 we have 64. 64. Is 60 equal to 64? No. Now we have to check the next condition. That is key less than A of mid. 60 less than A of mid. So here A of mid is A of 7. In A of 7 we have a value as 64. 60 less than 64. Now the condition is true. If this condition is true, now my search space is not this. Now the search space is here. Now the search space is this. That means it is not greater than the 64. Because I know this, because the elements which are there in this list are in sorted. In such a case, we have to change the high value to the left of the high. So that means in this case, high value has to be shifted, that is mid minus 1. So already high is equal to mid minus 1. Mid value is 7. 7 minus 1, now it is 6. So high value is shifted to 6. Now the high value is this. Now again we have to repeat the same procedure. First we have to find out the mid value. Then we have to check with the above 3 conditions. So here low value remains the same. Now low is 5. High is 6. Again in this case we have to find out the mid value. Now, so to calculate the mid value, mid is equal to low plus high by 2, where low is 5 by 2. Now it is, so this, we have to take the floor value, that is 5. So here we have the mid value. So here we'll take it as 5. Mid value. Again we have to go with the 3 conditions. First we have to check whether key is equal to A of mid. Key is 60 equal to A of mid, that is 5. A of 5. A of 5. In A of 5 we have 46. Is 60 equal to 46? No, this condition is false. So the next condition we have here, key, that is 60 less than A of 5. A of 5 is 46. Is 60 less than 46? 60 less than 46. Is 60 less than 46? No, this case is false. Now we have to check 60 greater than 46. Yes, this condition is true. That means we know that the key value is greater than the mid value. In such a case, we have to change the low value. Low, how to change? Low is equal to mid plus 1. That means the key value is greater than, it is right side of the low. So, low is equal to mid plus 1 in this case. So, mid is at 5. 5 plus 1. Now, low is equal to 6. So, we have to shift the low value to here. Now, low is also at 6. In such a case, high remains the same. Now, we have here 6. Low is 6. High remains the same, 6. Now, again, we have to find out the mid value. So, to find out the mid is equal to low plus high by 2. That is 6 plus 6 by 2. Now, here we have a 6. So, mid value is also at 6. So, mid is also at 6. Now, again go with the 3 conditions, that is key equal to A of mid. So, key is 60 equal to A of mid. A of mid is A of 6. In A of 6 we have 60. Yes. Now, the condition is true. So, next, in such a case, we'll print the element is present at a location. We'll print that location. The element is found. If the element is present in the given list of the array. Let us suppose if the element is not present. If the element is not present, let us take now the key value. Now consider the key value as 61. The key value is 61. So now we have to check whether 61 is present in the given list of array or not using a binary search technique. So this technique will work only on sorted list of elements. So if you observe, the list of the elements are in sorted order. Now first we have to find out the mid value. Then we have to check whether the key value is equal to mid or less than the mid value or greater than the mid value. If it is equal to mid, we will print the element is found. If not, we will divide the given array into sub-arrays left and right. Now to find out the mid value, it is low plus high by 2. So to find out the mid value, mid is equal to, we know that it is low plus high by 2. So always this is the low and here we have high. We can also take it as a left or a right. The number of elements are 10. And now, so low, high and mid. So in previous example, I have considered the key value as 60. 60 is present in the index 6, so I found. Now I have considered the key value which I want to search is 61. Now low is at 0, high is at 9. Now to find out the mid, that is 0 plus 9 by 2, it is 4.5. I will take the floor value as 4. So now here we have a mid value. So that is 4. Now we have to check with these 3 conditions whether we found the key value which I want to search or not. Now key is here 61. 61 equal to A of mid. A of 4, that is 26. No. So next condition is key, that is 61 less than A of mid. A of mid is A of 4. In that location we have 26. Is 61 less than 26? No. So we have to go with the next case, that is 61 greater than A of mid. 61 is greater than 26. Yes. Now the condition is true. That means the element which I want to search is greater than the mid value. That means it is right of the mid. So in such a case, we have to change low value, because now the search space is this. It is not there in this left array. So now we have to change the low value. If this condition is true, we have to change the low value. Low value has to be shifted to low is equal to mid plus 1. Now the low value, low is already mid is 4, 4 plus 1, now it is 5. So now here we have a low. So low value is 5. Now high remains the same, high is 9. Now again we have to find the mid value. So now mid value is, mid is equal to 5 plus 9 by 2. So it is 7. Now mid value is here. Now again we have to go with the 3 conditions. We have to check is 61 equal to A of mid, that is 64. No, this condition is false. 61 less than A of mid. A of mid is 64. 61 less than 64. Yes, now the condition is true. That means now my search space is this. Not after, that means right of the mid. We don't have the element right of the mid. It is less than the mid value. Why we know? Because the elements in this array aren't sorted. So in such a case, in this case, we have to shift our high value. That is, high is equal to mid minus 1. So now high value is shifted, mid minus 1, mid we have 7, 7 minus 1, now that is 6. So the high value is shifted to 6. In such a case, low remains the same. Now low is 5, high is 6. So again we have to find out the mid value. Mid value. So mid is equal to low plus high. Low is 5 plus 6 by 2. So we got 5.5. We'll take floor value is 5. Now mid value is 5. So now mid is here. Again we have to go with the 3 conditions. That is key. Key is 61 equal to A of mid. A of mid is 46. No, condition false. Then the next condition is key 61 less than A of mid. That is, A of mid is A of 5, 46. Is 61 less than 46? No. Then 61 greater than 46. Yes, 61 is greater than 46. This condition is true. That means the element which I want to search is right of the mid. In such a case, we have to change the low value. Low is equal to mid plus 1. Already mid is 5. Then low is equal to 5 plus 1. Now it becomes 6. Now low is at 6. Now low is shifted to 6. High remains the same. Again we have to find out the mid value. So mid is equal to low plus high by 2. Here 6 plus 6 by 2. So 6. So mid value is 6. Again we have to check with these 3 conditions. Key is here 61 equal to A of mid. A of mid is A of 6. In that we have 60. This condition is false. Then go with the remaining 2 conditions. 61 less than A of mid. Yes, 61 is less than A of mid. In A of mid, that means A of 6 we have 60. 61 less than 60. Condition is true. In this case, we have to change high value. High is equal to mid minus 1. So already high is now here we have mid. High is equal to mid minus 1. Mid is at 6. So 6 minus 1, that is 5. Now high is at the index 5. That means low crossed high. Low is at 6th position. High is at 5th position. Low crossed high. In such a case, the element is not found in the given list. The element is not present in the given list. When low is greater than high. Low is greater than high. This represents that element not present. We will repeat these steps. When low value is less than or equal to high. Whenever low crossed high, then the element which I want to search is not present in the given list of elements. So here we have an example program. So how many variables we need? We need an array, low, high, mid, n number of elements. The element which I want to search is considered as the key element. Found here, found acts like a flag variable. It takes only two boolean values, either 0 or 1. So initially I have assigned this value with a 0. The number of elements are 10. So here I have 10 elements. Then to read the elements and store into the array, I have to take a for loop because the elements are stored in a different locations. The element which I want to search here, I am considering as the key. The value given it as 18. So I want to check whether 18 is present in the given list or not. The given list is 12, 13, 14, 15, 16, 18, 19, 20 and 21. This is the list. I want to check whether the element is, the key element is 18 present in the given list or not. If it is present, I want to print the index position of the key value. So here low, I told you low is equal to 0, high is equal to n minus 1. Initially this is the low and this is high. Number of elements are 10. If I want this index, it is n minus 1. Now as I told you, I want to repeat the steps, that is key equal to a of mid, key less than a of mid, key greater than a of mid. We have to repeat these steps. The steps are key equal to a of mid, key less than a of mid, key greater than a of mid. We have to repeat these steps when low is less than or equal to high. Low is less than or equal to high. So first we have to find out the mid value. Mid is equal to low plus high by 2. Now I have to check whether key equal to a of mid. If this condition is true, initially found I consider as a 0. Now found becomes 1. Then break. If I found the value, no need to repeat the rest, no need to repeat the loop. Then I'll exit from the loop using a break statement. If this condition is not true, then we have to check whether the element is present in left sublist or not. So if that is present, then we have to change the high value to mid minus 1. If not, we have to check whether the key value is present in the key which I want to search is present in the right sublist of the array. If it is present so, then we have to change low is equal to mid plus 1. So now here I consider one more condition called if found equal to 0. That means when found becomes 1 when this condition is true. That means when I found the element which is present in the list. So if found equal to 0, that means I did not find the element. The element is not found. If found equal to 1, that means element present in the given list. So after that I am printing the element found at the index position %t comma mid. I am printing here index position, index of the key value which I want to search. So in the next session we'll discuss about quick sort. Thank you.